Welcome to Dora Tech Essential Series. Ease your learning.
In this video, we will learn about the importance of network interface cards. An individual computer accesses its data from a local storage, i.e. floppy, CD, HDD, etc. In order to share this data with another computer, we either need to use an external media, like USB drive, or connect the computers physically through some network. A network interface card, NIC, is a hardware component, typically a circuit board or chip, which is installed on a computer, so it can connect to a network. There are different forms of network cards based on their use, speed, portability, distance, and stability. Namely, wired, wireless, optical, infrared, removable, etc. The network card operates as a middleman between a computer and a data network, with a dedicated, full-time connection to a network. The NIC uses the OSI model to send signals at the physical layer, transmit data packets at the network layer, and operate as an interface at the TCP/IP layer. There will be a dedicated video on the OSI model. A Media Access Control Address, MAC address, is a unique identifier, assigned to a Network Interface Controller, NIC, for use as a network address. MAC addresses are primarily assigned by device manufacturers, and are therefore often referred to as the burned-in address, hardware address, or physical address. No two device will have same MAC address, as it will create conflict in a network. A MAC address, Media Access Control Address, is a 12-digit hexadecimal number, assigned to each device connected to the network. Above chart shows the number of values based on the number of bits used. Hexadecimal is a base 16 number system. That means there are 16 possible digits used to represent numbers. 10 of the numerical values, i.e. 0 to 9. The remaining 6 digits are represented by A, B, C, D, E, and F, which map out to values of 10, 11, 12, 13, 14, and 15. Hexadecimal generally represents 256 values as shown in the chart. Any number above 16 are represented commonly with 2 hexadecimals, which is 16 x 16 equals 256 values. Hence the hexadecimals start from 00 and ends at FF. A device here refers to a network hardware, as operating devices like computers, mobiles, and servers can have more than one network device installed. A MAC address contains 48 bits, that is 4 bits, for 16 hexadecimal values, multiplied by 12 decimals. The 12 decimals are further split into 6 pairs as shown above. The first three pairs are known as organizationally unique identifier, which a vendor need to obtain from a distributing authority, IEEE. Hence first 24 bits are for vendor, and the rest 24 bits are for the device. Manufacturer may obtain more than one WI from IEEE. This acts as a license number for the manufacturer to produce 2 to power 24 equals 16,777,216 network devices in total. As electronic devices generally have warranty for 3 to 5 years, the manufacturer may reuse the oldest OUIs if necessary, in case they are running out of OUIs. Multiple network connectors were developed during their lifetime which had their own limitations. The most common connector used currently is the RJ45 connector. The RJ45 connector contains 8 pins in total, but only 4 pins are used in networking. 1 pair for transmitting data, and 1 pair for receiving data. The RJ45 connector uses a twisted pair cable. The more the twists in cable pair, the greater signal strength and data bandwidth can be achieved. The above chart shows some categories of twisted pair cables, their bandwidth capabilities and distance limitations. A category should be selected based on the type and speed of the network card you are using, as the price increases with each category. This is an example of pin number layout of RJ45 connector. We use only 2 pairs for transmitting and receiving data. The transmit pair goes to pin 1 and 2. The receiving pair goes to pin 3 and 6, rest pairs are filled in the blanks. The above diagram represents a commonly used straight-through cable, to connect a system to a network switch. To connect 2 systems directly, we need to use a crossover cable, where one system's transmit pins go into other systems' receiving pins. The RX and TX pin number remains same, we just swap the 2 pairs on the other end of the cable as shown above. The selection of network card and cables go hand to hand, as it can operate at the highest available speed of either card or cable. Above chart shows some available card/cable speeds while selecting them. Here is another example of how much data you can transmit/receive over the network with a specific card/cable. The speeds mentioned are for each pair, hence the TX will have its own speed and RX will have its own. We can use network couplers to join 2 short cables, to achieve the desired length, but the overall length limitation of 100 meters will still be applicable. Hope you enjoyed the series. More to come soon. Like, share, and comment. Press the bell icon and subscribe to get notified about upcoming videos.